In this lesson, we are going to talk about Active Directory users and groups. Windows uses user and group accounts to control who can do what within the system. In addition, user accounts allow you to create a custom computing environment for each individual end user, while they're using that Windows system. Therefore, an important aspect of managing a Windows system is knowing how to manage these user and group accounts. That's what we're going to talk about in this lesson. Let's begin by talking about user accounts. Anyone who wants to use a Windows system must first authenticate to that system before they're going to be allowed to do anything. By default, the end user has to supply two different pieces of information. First of all, they have to supply their username. They also have to supply a password associated with their username. Sometimes you're going to hear these two pieces of information, the username and the password, referred to as the user's authentication credentials. If the user supplies valid credentials, then they're going to be granted access to the system. If they don't supply valid credentials, they're not allowed to log on. If they are allowed to log on because they did supply valid credentials, then the tasks that user is allowed to complete within the system will be constrained by the permissions and the privileges that have been assigned to that user's account. Please be aware that there are other authentication mechanisms that could be used to log on to a Windows system. For example, you could use a smart card, or you could use biometrics and all. We're not going to talk about those in this lesson because they have to be manually configured. By default, Windows is just going to require the name of the user, along with that user's password, in order to log on. The location of the user account and the way the authentication process works can actually occur in several different ways. The first one is called local authentication. If a Windows system is configured to use local authentication, then the usernames and the passwords for every user are stored on the local system itself. When this user supplies a username and a password, it is going to look up that username and password in its own database of user accounts, and it's going to verify that the password that the end user entered matches the password stored in the database. If it matches, then the user is allowed to log on to the system. If it doesn't match, then the user is prevented from logging on to the system. Local authentication is commonly used in standalone configurations. In that situation, there are no other Windows systems on the network. Local authentication can also be used in a workgroup deployment, in which case there are only a very small number of Windows systems on the local network. In the example you see here, we have 3 different systems connected to the same network segment, and they all are members of the same workgroup. In this situation, each have their own database of user accounts and passwords. They don't share them. As long as the number of systems on the network is about 10 or less, you can get away with using local authentication, storing usernames and passwords individually on each of these systems. But be aware that if you have a really large Windows network, then using local authentication really isn't feasible. It doesn't scale well. The key problem is the fact that these user accounts are not shared between systems. Each system has to have its own unique set of user accounts. So let's suppose I have a user and we have a workgroup set up here, and I have a shared printer and a shared folder over here. Notice that the shared printer is connected to this system, while this shared folder is connected to this system. This is the system that user logs on from. This is the computer that's sitting at user's desk. Therefore, in order to log on, the user has to have an account on this system. So, when user logs on, the system will check its database of user accounts. If the username and password are correct, user is allowed to log into this system. Then, when the user wants to access a file in a shared folder, the user has to then authenticate to this system first, and this system is going to look for a user account in its database of usernames and passwords. If the username and password that user supplies is valid, then she's allowed to access the shared folder on this hard drive, right here. Let's scale up this example. Let's suppose that instead of 3 different computers on this network, I have 100 different Windows systems and 100 end users. Each user has their own system, but just like in this example, each user may need to access resources, such as shared folders or shared printers, on other user systems. To make this work, you'd have to manually create 100 user accounts on each of the 100 systems, and try to make sure that the password stayed in sync on all of the different systems all of the time. That's really a piece of work. Therefore, domain networking is used. Understand that it's possible to store user accounts and passwords on a remote computer somewhere else in the network. Typically, this is done using a server that's configured to function as a domain controller. In this situation, each workstation can be configured to forward the credentials that are entered by the end user to the domain controller. The domain controller stores a shared database of user accounts and passwords, so it's going to compare the credentials that were supplied by the user at the workstation to its database of user accounts and passwords, and it's going to verify that the username and passwords supplied are valid. If they are, it's going to go ahead and tell the workstation to grant the end user access to the system. For this to work, notice down here that the username supplied is slightly different than we saw before, with local authentication. But you can see here there is one difference. We are providing the domain name before the username to tell the computer that this user belongs to this domain, and you should authenticate from the domain. Using domain authentication has many advantages over using local authentication. First of all, only a single database of user accounts is required, and it is stored centrally on this domain controller, right here. Therefore, the credentials stored on the domain controller can be used to authenticate users to any Windows system in the network, as long as it's been joined to the same domain as the domain controller. Because of this, you don't have to worry about setting up and managing duplicate user accounts on each system. You define the users once, right here on the domain controller, set up their account and their password, and then that user account can be used by any other Windows system within the domain. As a result, this user's domain account can be used to manage access to network resources throughout the domain, instead of just on one local computer. For example, if user logs onto this computer right here, her group policy settings are going to be applied to this system because they're defined at the domain level. If for some reason that user needs to come over here to a different office and log onto this computer as her same user account, then those very same group policy settings are going to be applied to this system. This ensures that the same computing environment and security settings are applied to the user no matter what computer they're logging on to the domain. In Windows 8 and Windows 10, it's also possible to use a different authentication method called online authentication. In this configuration, the user first creates an online user account with Microsoft. Then, when the user needs to log onto a system, Windows will submit his or her credentials online, over the internet, to Microsoft for authentication. In this situation, the username and password are compared with the credentials configured for the user's online account. If they match, then the user is allowed to log on. Now let's talk about using groups on Windows systems. Understand that a group is kind of like a container, or a bucket, if you will, that can hold one or more user accounts. Using groups has a lot of advantages on Windows systems. For example, let's suppose that you have a particular Windows system, and you have multiple user accounts defined on that system. From all of the users, let's suppose that some of them pretty much need exactly the same level of access to the system. There's nothing unique. They all need, basically, the same access to the same resources. Without groups, you need to go into each of the individual user accounts and manually assign the necessary user rights, access policies, and permissions redundantly, over and over and over, for each one of the user accounts. That is a lot of work. To make things more efficient, you can implement groups. Here's how it works. First of all, you assign the necessary user rights, policy settings, and permissions to the group, not to the individual user, so you only make the assignments once. Then you go and make all of the users that need the same level of access to the system members of that group. When you do, all of the members of the group automatically receive whatever rights, policies, and permissions that you assign to the group. That's it for this video. In this video, we talked about Windows users and groups. We reviewed the role of user accounts. We talked about the different ways users can authenticate to a Windows system. Then we discussed the role of groups and reviewed several of the default Windows groups.